I just used recode to go over build graph, and now I'm going to use recode again to go over shortest path. Recode at a high level is a way that I study a problem that I find a problem that I don't already know how to do, like a leak code type problem, and then I use recode to get to the point where I can type out the problem as quickly as, like, the limiting factor is my fingers, how quickly I can type. So, for example, now that I've done that with this code here, I can delete it all and then retype it out. And so I'll do the same thing with this. I'll show the steps from how to get to from the point where I don't exactly know what the algorithm is to the point where I can just type this out. And a little bit of it is done already. There's a bunch of comments already, and I've already copied the code. I have a solution. I've copied the code. So if I go to solution, that's here's a solution for that part, and then here's a copy of this part solution, the actual shortest path finder. So if I go back to here, this is the one that I'll be working with. So I'll find the innermost portion of the code, and so here that looks like that. Maybe there's something else that's a little further. So that looks like it's a little further indented than this line. Yep. Is there anything further than that? No. Okay, cool. So this right here is the furthest indented line of code. So I would write this, then delete this, see if I can rewrite it using this comment. If not, then I can go refer to the original, the copy that I made that I just mentioned. So here I can go there. No. Looks like I used continue a few times. Oh. Yeah, this is the right place. The line numbers are slightly different, but that's because this has a bunch of commentary. Anyway, that this one doesn't have. So this is the one that I'm going to be working with. From this comment, if I can't recreate this line of code, then I would refer to my solution that I made a copy of. And I also already have tests. So if I go like that, it's running a test, and this is what it looks like for the test to be successful. It doesn't tell me that there are any problems. So yeah, so I'll go ahead and so that's a description of what it's like to do recoding. So I would make this comment, delete this line of code, see if I can make it from this comment. If I can't, I'll go refer to the original. If I can, then I might, I'll work my way outwards. So that would be, there are no siblings to this line of code, so I'll work my way outwards to here. Then I would write this comment. This will be just a description of how it works, and then I'll actually do it in a minute. And then this has sibling lines of code, so lines of code that are at the same level of indentation. That's all of this stuff. And then once I'm done with all of that, I would do this and all of its siblings. And once I'm done with that and all of its siblings, that actually might be nope, it's not the highest level. So I would do this thing and all of its siblings. And siblings are lines of code that are indented the same amount. And so I would write comments for each one of them and then rewrite the code based on the comment. Okay, so I think that was here. Okay, so now I'm going to start and actually do what I just said. I'll start without all of the comments. So I'll just take away all of these comments because I have them in the copy as well, so it's easy enough to bring them back. And just to be sure that I didn't somehow mess up, I'll rerun the test. Okay, that's good. So now here is all of the code and it only just barely needs a little bit more space than I have vertically to show it all at once. This is the most indented line of code, so go to next iteration of for loop. Okay. How do I go to the next iteration of the for loop? I'll do continue. And let's rerun the test. It works. Cool. What about if so now I'm done with that line of code and all of its siblings, so I'll work my way outwards. What is this? So if I've already seen the neighbor, if I've already seen the neighbor, then go to the next iteration of the loop. So if if I've already seen the neighbor, where is my list of seen things? Visited? I should probably rename that. Dot has is visited is a set. Okay, visited dot has neighbor. Then continue. Bring that up there. Let's see if I did that correctly. I did. Okay, cool. And let's go to the solution. If visited.has neighbor. Okay, so this is the copy that I made at the beginning, and it looks like it looks the same, so that's cool. Okay, so now I've done all of that, and I'm at this level of indentation, so the next line would be this one, so I'll comment that. What is going on here? So we have a queue, and we're putting onto it the neighbor and the distance to that neighbor, which is one more than the distance to the thing that we, like, whatever node this we got to this neighbor from. So add to the queue the neighbor and distance to that neighbor. Okay. Queue dot add push. What kind of thing is queue? Queue is a list. Okay. Queue dot push the combo, and I can see up here things in the queue are pairs of node and distance. So down here we can do node is the neighbor, and the distance will be the distance to the current node. So that's this node here, because we got neighbors of node. That distance plus 1. Push. Why doesn't it like... Oh, plus 1. That distance plus 1. Okay. Let's go rerun. Oop. Oh my goodness. Let's go here. Rerun the test. Cool. Test. Cool. So it looks like that worked. Let's change that to a 2 just to be sure that this is actually running. Okay, cool. So change that back to a 1, go back to the test, rerun it. Okay, that's what we want. Try this again. So we're gonna add to the visited.add, add the neighbor to the or mark the neighbor as a visited node. Okay. Can I do that? Visited dot add neighbor. What? No. Oh my goodness. Keyboard. Okay. Did that work? Yes. Okay. Take that out. Just be sure. Uh-oh. That's not good. I'll have to look into that. To do, find out why removing this line does not, why tests still pass even after removing this line. Yeah. Why is that not okay. Even after removing this line. Okay, so where is visited used? Here. So maybe all of my tests don't actually never encounter or they don't change based on this. All right. So now that I'm done with that, I think I have done everything inside of this for loop. So I'll try commenting the for loop. So let's see, for const neighbor of neighbors, for every neighbor. Oh no. I'm going to leave it like that. Oh, but in order to run the test, well, yeah. For const neighbor of neighbor, and I remember that it's of now because I can remember that when I want to check whether a key is in a collection or in a dictionary, I use of. And neighbors is going to be an element of a collection. So neighbors is going to be whatever is inside of graph at node. Neighbors is, I changed it to be a set. So graph at some node, it's a collection of key value pairs where the key is a node name and the value is a set of neighbors, direct neighbors. Anyway, of gives me elements of whatever this collection is. So I remember, as opposed to in here, for every neighbor. So I want every element of some collection of elements, or for every item of a collection of items. And not in. In does something different. All right, so now that I have done that and recreated that, I'm also going to delete all the code and recreate it, and I'll come back to this later. Alrighty. Oh, I didn't actually test it, so let's run the test. Again, it would be super cool to have something that reruns that and then puts an icon somewhere down in this bar or up here or something that turns red or green and is an X or a check or something based on whether this returns success or not. If somebody knows of such a thing, let me know. That would be awesome. It looks like that worked. So now I'm going to try deleting all of the code. Okay, and I'll try rewriting it from scratch. So for const neighbor of neighbors, I will, if I've already seen the neighbor, if visited.has neighbor, then go to the next iteration of the loop, continue there and there. And then otherwise, add the neighbor to the queue, the neighbor and the distance queue dot add neighbor and distance plus 1, because this distance is the distance to node, so the distance to neighbor is distance plus 1. q.add that, mark the neighbor as visited, visited.add neighbor, even though that seems to not actually change anything, which is weird. And I'll come back to that. Okay, let's go check. Did I just go here? Does it still pass? No. Unexpected end of input. Did I skip a curly bracket? No. Oh, yes, I did. Curly bracket. Okay. Did I save? Yes. Q.add. Q.push. Okay, so here it's mad about q.add because q is an array. So I change it to push, and I didn't save, so let me save, and then try running it again. Okay, now it works. Cool. That all seems good. Okay, so this whole thing is good. So that's that whole for loop. Neighbors, let's see. Neighbors is all the neighbors of node. Const neighbors equals graph the value associated with node. Go test it again. Okay, that's cool. Try this. There isn't really a better, like, I don't know how else to say this in English. There isn't a more abstract way of saying this, I don't think. Okay, now I'm going to try, well, let's go run that, and I get errors. Okay, cool. Bring that back. Don't get errors. Okay, cool. So that means that that line of code brings it from an error state to not an error state. Although, as we've seen, maybe my tests are incomplete, or my tests are definitely incomplete. If node B is the node if node is the same as node B, that's what this if statement says. If node equals node B, then we'll do this. Nailed it. If that is true, then we'll do that. Let's try doing that whole thing. If node equals node B, then return distance. Distance. Okay. Okay. Cool. Let's try get node and distance from the queue. Okay. Const node distance from the queue dot shift. I think shift is the one that brings things off. Yeah, it is, because that's for command line stuff. Use shift. Okay, cool. Okay. So is that everything inside of the while loop? Yes, it is. Okay, so we're about to do a lot inside of the while loop. Starting with the opening, so while the queue still has things to nodes to process, okay, go like that, and we'll go to the other end. Okay, while 0 is less than queue dot length, go like that, and see where the other end is. Here. There. Did I get that correct? Oh. Yes. Okay. Cool. Now let's try deleting all the code. Oop. Delete all the code, but leave the comments. Okay. Oh man. And the indentation. While 0 is less than queue.length. There we go. Down to here. Oh. Okay. I guess my auto indenter isn't going to let me put the close curly bracket and keep the indentation, so I will put it after doing all the other stuff. Okay. Get the node const node distance equals queue dot shift, because we're going from the front end of the queue. If node equals node B, so this is node B is like the target, so I might rename this. I'll put that as a to-do. Rename node B as to target, and to-do. And then another to-do would be to-do along those lines. Node A could probably be renamed to start. Rename node A to start. I think that makes sense. Okay, so we have get node going back to rewriting. If that's true, then return distance. Return distance. Okay. Neighbors is all the neighbors of node O. Const neighbors equals graph all the things associated with node. I think it's called graph. Yeah, it's called graph. Okay. And for every neighbor, for const neighbor of neighbors, then we'll do, oh, that didn't cause the indentation to go away. Cool. If I've already seen the neighbor, if visited dot has neighbor is visited is a set, okay. If visited has neighbor, then go to the next iteration of the for loop, continue. I think visited, a better name for visited would be seen to do. Rename visited to seen. I don't know why I did that one different than these, but whatever. So if we have already seen the neighbor, go to the next iteration of the loop. Doot. Doot. Add to the queue the neighbor and the distance to that neighbor. q dot push the neighbor and distance to the neighbor from the start. So distance is the distance to node from the start. That's why we have to add the 1. Mark the neighbor as a visited node. Visited dot add neighbor. And again, we saw that that didn't really have an effect on any of the tests. Mark the neighbor as a visited node. Find out why the test. So go move that there, and move that there, and move that also there. And then that's the end of that loop that I needed to remember to insert later. Go back here, rerun that. Looks like it's good. Is this saved? Yes, it is. Okay, everything's good. Okay, so now we've done the entire while loop. Let's do all of these. So graph is built from edges using build graph. Okay. Q, well, let's do that first. Const graph equals build graph from edges. Okay. Run the test. Cool. Q is initially a list of a pair of node A and distance 0. Okay. Q, const Q is node A and 0. Okay. Visited is a set containing node A. That's this. Oh my goodness. Try that one more time. There we go. Const visited equals a set created from node A. Okay. So now I have recreated all of that. Here's one more sibling, return -1. And the reason we do that here is if we get here, then there is no path from start node A to node B. That's the only way we could get out of this while loop. If we process all the things if we ever get to an empty queue here, then that means there's no neighbors left to keep checking. So let me bring that code back and go run the test. Okay, cool. Return -1. Delete that code, return -1. Run the test. Cool, that worked. Alrighty. So now we're at the point where we should be able to delete all the commentary, all the code, leaving just the commentary. And recreate it because we can read the commentary and we know what we are supposed to do. Okay, so the const graph equals build graph from edges. Okay. Const Q equals node A and 0. Const visited equals, and I already have rename visited to scene. Okay, cool. new set containing node A. Okay. While the queue is not empty, queue.length. I just have in my head the way to check whether queue is empty is just check whether 0 is less than. Okay. So get the node and distance from the node, from the queue. Const node distance is equal to queue.shift. If the node is the same as node B, so if node equals node B, then return distance. Okay. That there, that there, that also there. Okay, don't save yet. Neighbors is all the neighbors of the node. Const neighbors equals graph, I think it was, at node. Is it graph? Yes. Graph at node. Okay. And then for const neighbor of neighbors, then if I've already seen the neighbor, so visited dot has neighbor. If that's true, then go to the next iteration, continue. So for every neighbor, that goes there, that goes there, and that goes there. Go to the next iteration. Okay, and then that goes there. Actually, can I? Oh, that does not go there. That and that go there. Can I cut this and paste it? I think I remember losing indentation doing that at other times. Anyway, add to the queue the neighbor and the distance. Okay, so queue dot push the neighbor and the distance plus 1. Okay. Mark the neighbor as visited, visited.add neighbor, and find out why that doesn't seem to make a difference to the test at the end. And then return -1. Okay, that all seems to make sense. Did I do it? I did. First try, 0 deaths. Alrighty, now for the big one, can I do that all without any comments? Okay, so we need to build a graph, build a queue, build a visited. The queue will initially is going to have pairs of things. It's going to be the node and the distance to that node. That's what goes on the queue. Visited, we're going to say that we've already visited node A, and then we will keep doing stuff while there is stuff on the queue to do, and the stuff that we do is go through every neighbor, which means we have to figure out what the neighbors are. Well, the first thing we'll do is check whether we're at the finish line, and if we are, we'll return the distance. Then we'll go through every neighbor. I think I can remember all of this. Keep working while there's work left to do. The work is go through every neighbor of the current node and add it to the list, with the special case that if we've already seen it, then we don't add it to the list. So we'll just go to the next one. So we add it to the list of work to do, and we also make sure that we remember that we've seen it already. so that we can do this, which apparently I don't have any tests that actually test this. And then if we get through all the work, then we return -1. Okay, I think that all makes sense. Let's find out. Can I do it? Yes, I can. Actually, before doing that, do one more, just make sure. Okay, cool, that works. Then get back to here, and we'll say const graph is build graph from edges. Cool. Const q, what work do we have to do? That will be a list containing node A and a distance of 0. This is the work that we need to go through. Node A, this thing is the only thing on the list of work that we need to do, and it's saving some information for us, which node and what distance that node is from the start. Okay, and then const visited is going to be a set containing just node A. And while there is more work to do, q.length, while that's true, we will grab out of the, get all the neighbors, const neighbors of the current node. Okay, so we need a current node. Const node equals q.shift, and it's not actually going to be a single thing. It's going to be a node and a distance. Well, okay, so first we get that, then all of the neighbors is going to be graph at node. Then we can do for const neighbor of neighbors. Of is the one that gives me, makes it so that neighbor will be every element from this collection of elements, not every index in an array. Okay, so neighbors is equal to that. If we have seen, so if neighbor, if visited dot has neighbor, if that's true, then we go to the next iteration of the loop. Otherwise, we say we add to the queue, so queue dot add, no, push, right. We want to put specifically at the end of the queue. Push will do that, and add is for sets. The neighbor and the distance +1 because it's a neighbor. And we also do this, even though we know that it doesn't do anything right now, for the tests that we have. And if we get here, we return -1. I don't have a return statement anywhere in here. If the neighbor is the node that we're looking for, then return the distance to that neighbor. Is that right? No. Here, if the node is the node that we're looking for, then return the distance to that neighbor. It's not what I just had, because distance is the distance to node, not the distance to neighbor. So bring that back up here, node, okay. And this almost, without all those comments, it almost fits on one screen. Is it correct? Let's find out. Hey, awesome. I really did not know whether that would work. Oh, I could make this a little bit shorter. Will that? No. My auto formatter doesn't let me do that. Will it let me do this? It will. Okay, cool. Yeah, now it all fits on one line. Ha, awesome. Or one page. Did that mess it up? No, okay. Okay, cool. So that's what recoding shortest path looks like.